Tokyo once attempted a skyscraper so ambitious that even today, with all our advanced engineering, experts still question whether humans could ever build it. Imagine a structure so tall it reaches into the jet stream, so massive it becomes a self-contained city, and so complex that it would need its own weather system. Sky City was projected to cost well over $100 billion, making it one of the most expensive construction projects ever imagined. This wasn't science fiction, it was a real proposal, and if it had been built, it would have rewritten everything we know about architecture. The story begins during Japan's explosive economic boom of the late 1980s, a period when Tokyo seemed unstoppable. Land was disappearing, prices were soaring, and the city's growth had pushed architects into a race toward the sky. This era produced some of the boldest architectural visions ever imagined, but none were more extraordinary than the proposal known as Sky City 1000. The name alone revealed its ambition. This wasn't another skyscraper chasing world records. Sky City was conceived as a 1,000-meter tall vertical metropolis, nearly 3 times the height of the Empire State Building and far taller than any structure on Earth at the time. But the height was only one part of the vision. The tower was designed to be a self-contained city capable of housing 35,000 people. Inside one single structure, residents would have access to homes, offices, parks, schools, shopping centers, hospitals, and recreation spaces. The idea was simple but radical: an entire urban ecosystem stacked vertically. The firm behind this audacious concept was Takanaka Corporation, a construction company founded in 1610 with centuries of experience. No one had ever attempted a building with this level of complexity, and no one knew how the physics of a structure this tall would behave. To grasp the scale, imagine 180 floors, each one larger than a city block. The tower would require express systems capable of traveling hundreds of meters per minute, delivering residents to upper levels in minutes instead of the hours it would take with conventional lifts. But the engineering challenges climbed with the building's height. At 1,000 meters, Sky City would rise directly into the jet stream. The wind forces at that altitude are powerful enough to shake large aircraft. The top floors would often sit above the clouds in clear sunlight, while the lower levels were surrounded by fog or rain. Then came the question of construction. The traditional method of building skyscrapers floor by floor was out of the question. Instead, Takanaka envisioned massive prefabricated modules, assembled off-site and lifted into place using crane systems that didn't exist yet. Entire sections of the building would be constructed like giant puzzle pieces and locked together in the sky. The foundation required its own engineering breakthrough: an underground support system so deep and wide that it functioned like an inverted skyscraper beneath the surface. It had to withstand not only the incomprehensible weight of the structure, but also Tokyo's frequent earthquakes and the constant motion generated by tens of thousands of people inside. The construction timeline was equally ambitious. Takanaka believed the entire tower could be built in just 8 years. That meant thousands of workers operating around the clock, managing a supply chain comparable to a military operation. Safety was an even more complicated problem. Fire evacuation in a conventional tower is difficult enough. Evacuating tens of thousands of people from a 1,000-meter building bordered on impossible. The building essentially needed its own internal emergency services, firefighters, medical teams, and security forces permanently stationed throughout the structure. But supporters argued the building could generate the revenue of an entire city district. With residential rents, commercial leases, retail income, and tourism, the tower could theoretically become an economic engine of its own, employing tens of thousands during both construction and operation. City planners worried about the impact on Tokyo's infrastructure. Environmental groups raised alarms about the ecological consequences of constructing a structure of this magnitude. And international experts wondered whether the necessary technological breakthroughs could realistically be achieved within the proposed timeline. Then came the shift that would ultimately seal Sky City's fate. As the 1990s approached, Japan's economic bubble began to deflate. Investors who once poured money into visionary megaprojects suddenly grew cautious. The sheer scale of Sky City, once a symbol of limitless ambition, now looked like a financial liability. And in an era of tightening budgets and uncertain markets, $100 billion vertical city became impossible to justify. Yet, even though Sky City 1000 was never built, its influence has been enormous. The concept pushed architects and engineers to imagine cities that grow upward instead of outward. Today, as the world faces population growth, housing shortages, and sustainability pressures, the principles behind Sky City, dense vertical living, mixed-use design, self-contained infrastructure, feel more relevant than ever. The legacy of Sky City 1000 is not defined by its failure to rise above Tokyo, it's defined by the imagination that inspired it. So the real question is this: with today's technology and tomorrow's innovations, should humanity attempt a project like Sky City 1000? Let us know your thoughts in the comments.